In algebra, sometimes we are asked to prove identities. So just like in geometry, where you are asked to complete a proof, you were given that, and then you had your goal for the end, what you wanted to have as your final statement. It's similar here in algebra, but we have a left side and a right side of an equal sign. You are never going to cross over the equal sign. That's super important. You're going to work with one side at a time. And then your last step should be showing that they're equal. And then I'm going to put a check. I've proved it. I'm done. So if I'm looking at example 1, I have the left side a plus b squared, and then the right side a squared plus 2ab plus b squared. So you want to work with the side where there looks like there's something to do. On the left side, I have an operation, multiplication. On the right side, it's already in standard form. So I'm only going to work with the left side. So I'm actually going to cover up the right side and pretend it doesn't exist right now. Remember that something squared really means you're multiplying it by itself. So you could double distribute if you want, or we can use the box method, which I'll show down here. I have a plus b, a plus b. A times a is a squared, a times b is ab, b times a is ab. We like to write things in alphabetical order. It's just easier, especially when we're combining like terms. And b times b is b squared. On my diagonal, I'm adding my like terms. So I have a squared plus 2ab plus b squared. Once you're done simplifying one side, you're going to compare it. If I look, this is what I want the right side to be. So now they are equal. I've proven my identity. The left side equals the right side. For number 2, it says, is the following equation an example of an identity? So is means my answer needs to say yes or no. So sometimes they may not be identities. So you have to be careful when you're reading the questions. Justify your answer, of course, means just show the math. So once again, left side and right side, I'm going to work with the side where there's something to do. In this case, the left side, there's nothing to do. I'm just going to bring that down. I'm hoping that when I go to simplify the right side, they equal each other and I'm left with x cubed plus y cubed. But for now, I'm going to cover it up. So I have the box method. I have 2 by 3. So I'm going to set up 3 columns, 2 rows. So I have x plus y, x squared minus xy plus y squared. X squared times x is x to the third. X squared times y is x squared y. Negative xy times x is negative x squared y. Negative xy squared, negative xy times y is negative xy squared. Y squared times x, keep it in alphabetical order, just makes it easier, is xy squared. And then I have y squared times y is y cubed. Combining my like terms, which end up on my diagonals, or if you want to list everything out so you can see it better, you can list everything out. That's fine too. You should see either way that this is going to cancel with that, as well as those, because they are additive inverses. I'm left with x cubed plus y cubed. So these are equal. And remember, I had to answer yes or no, so my final answer should say yes. It is an identity. So that's how we work with multiplying identities in algebra. The same is going to be true in future units. It doesn't have to be multiplication. Any kind of identity in algebra, you work with one side and you leave the other side alone.